Yes, please.
Hello Nitish, am I audible?
Yes, sir.
Where are others?
Sir, I don't know. Sir. I think they'll join. Good evening, sir.
Evening. Contact them if they're joining
Yes,
or
sir.
not.
Yes, sir. I'll call.
Good evening, sir.
Evening. You all have revised?
Yes, sir, I'm done studying.
We'll wait for 2 more minutes and we'll start.
Yes, sir. Nitish, why did you call me?
Good evening, sir.
Evening.
Sir, I have a doubt.
Go on.
Hello. Sir, can we leave if our doubts are cleared?
Can we?
Leave the meeting if our doubts are cleared or...
Why do you want to leave? Is there any problem?
No, sir, just to like study for the other exams. Because I'm finished studying physics, so like, if I'm asking if we are done, can we leave?
We'll be discussing some questions today. I don't know what time it will be taking.
Oh,
But
okay.
so if you
So
want to
It's
we
given
leave,
have,
us 2 hours.
yeah,
hmm?
so we can discuss all
It's
types
two
of
hours.
sums, all types of numericals and our doubts, sir.
Tarun won't come now, sir.
Okay, so we'll be starting.
Tarun will come like 30 minutes late, sir.
Okay. Yeah, so that day we discussed the motion in a straight line. Na?
Yes, sir.
Today we'll be discussing some questions, and first I'll be marking you some important topics related to laws of motion.
Yes, sir.
Okay.
Sir, am I clearly audible?
Yeah, you are.
Oh my god, Nitish. What
Yeah.
kind of 5 rupee camera are you using? Why is it like so?
I know.
No, I don't know. I think the virtual background makes.
Okay.
Your
So all of
face
you
is
open
one
your book.
pixel.
All of you open your book.
For me, it's clear. Why?
1 second, sir.
It is 1.080p.
So what, sir? Page number?
No, I said that Nitish video is like 1.080p.
Oh.
Sir,
Oh,
for me, it's clear, sir.
for
I
us
don't
how
know.
it's looking.
What?
Okay, all of you try to open your camera if it is possible. Nitish, you try to rejoin.
So for some
Net.
reason, this camera is not working, sir.
That
Okay.
performance
Problem.
score is good only, no, sir. Why is
Sankalp, we know your camera is working. You just turned it on.
he is in
Oh, yeah.
resort, huh?
See? Palkaj.
Sorry, sir.
Okay. So all of you open your book, Laws of Motion today.
Laws of motion.
That is
Yeah.
coming now.
Yeah, this the hardest one among all.
Sir, but you told to us to study the second and last, right, sir?
Yeah,
told to
loss of motion is
revision.
second chapter, lah.
I told
No,
you
like
to complete this.
No, sir, you told us to study
Motion
the
straight
equations
line,
of
laws of
motion and
motion and
magnetism,
magnetism.
right, sir?
I
Yeah.
asked you to do
He
motion
told
and
us to
straight line,
study
laws
all.
of motion and magnetism.
He told us to study all the chapters.
He told us to do all three.
Yeah.
You forgot it?
Sir, I heard you saying only the first and the last chapter.
No.
Studied
It's okay,
everything.
sir. I'm good at this chapter.
Okay. So, okay. Mark the important points. Open your book. Okay. Shall we start?
Yes, sir.
Right. So the first thing that you have to consider about is the definition of force is very normal. Then contact forces and non-contact force. So be careful about the like different examples of contact forces and non-contact forces. Okay, they may ask that about the spring force or the contact force or the like reaction, normal
They will
reaction.
ask diagram also, most likely.
They may ask. You should be writing you should be providing with the diagrams because every answer of science ends with a diagram. Okay, if you are writing as well as showing the diagram, that means you know more than, and then the teacher is also helping with your answer. So try to write the diagram, draw the diagram so that they understand that you know the things. Next, contact
sir.
and non-contact force. Learn all examples. So the general characteristics of contact force, general characteristics of non-contact forces also. Okay. So gravitational force always attractive. Magnitude of non-contact force depends on the distance between them. So it increases with the increase in distance, right?
Yes, sir.
Yes, sir.
If you bang your head, I said the non-contact force increases with the increase in distance. How do you say yes?
It decreases with
On
increase
contact.
in,
Oh,
it decreases with increase.
indirectly proportional. Go back.
Careful here. Be careful here.
Yes, sir.
Okay. So Newton's first law of motion, that is laws of inertia. So you have to define what is inertia, statement of inertia, statement of all the three laws of motion. Okay, that all of them are important. So statement they may ask. This is all about theory. Numericals will do. Okay, in this class, but this is all about theory that I am discussing, which are important. So what are the like conclusion of inertia that Galileo's law of inertia that he gave with this conclusion of his experiments? So what was the two conclusion that he gave? Pangwe?
Sir?
So what's the question?
What was the conclusion of Galileo's experiment of laws of inertia?
Okay, yes, sir.
Sir, he stated that an object will continue to move in the same path unless and until an external force disturbs it.
Okay. Now, What is second law of motion, Nitish?
So
Sir,
second law of
Galileo, right? Sir, you said Galileo.
Yeah.
yes, yes.
Yeah. I finished answering
Galileo
that.
also stated that the mass does not
He
matter
already
with the.
answered, Ra.
No, I'm just.
That is there. There, Galileo's experiment, Galileo's laws of inertia is there, and then from the discussion, the two conclusions were there that Kongwe told right now. Yeah. What is the statement of second laws of motion, Nitish?
So the second law of motion
Come
states
on,
that
Nitish.
the second law of motion states that states the force needed
Even with this
to
pixel
stop
system, we can see that you are turning the pages.
me, sir.
Yeah.
I know it's we can hear
Okay.
it.
Now can you
Like
see
the
my hand?
sound is coming.
Okay. Now can you see my hand?
Try to rejoin. That is too bad. The screen is coming too bad.
Yeah.
So I'll just remove my stupid background, sir.
Yeah.
Yes, sir. Now can you see my hands?
No, even now it is the same.
No.
Some problems
It's
there with the
not your
camera.
virtual background. The entire video is like
Yeah, you
like
try
very
to rejoin the
pixelated.
camera.
Hey, now turn on your video. No. Plug your camera properly.
It's a laptop though. What do you mean?
Oh, it's
One second, I'll leave
laptop
and join,
camera.
sir. Sir, 2
No
seconds.
webcam.
Yes, Uncle, what is the second law of motion statement?
Sankalp.
Sir. I'm not sure.
Sankalp.
I am not sure.
Hey,
You have exam. Congo, you tell.
Sankalp. You can't do like
Sir,
this.
sir, that's
the-
the only thing I get confused on, sir.
Should be practicing more now. Congo, you
So
tell
can
what is
I
the second
tell?
statement? Yeah.
Yes, sir. Newton's second law of motion is the law of change in momentum, that is P equals mv, and its derivation is F equals ma.
I need the perfect statement that I have made you written. The statement says that the rate of change of momentum gives you the force.
Yes, rate of change of momentum.
Remember that. Remember that these statements are
Oh,
most
the
important.
linear momentum. Sir, so we are supposed to learn that linear momentum one for the second law
Now is
definition.
it visible, sir?
Yes, Nitish, we can see you now.
Sir, can I
Go
say
on.
now the
Yeah,
statement of second law of
yeah,
motion?
go on.
Sir, the second law of motion states that the force is equal to the rate of change of momentum. That's
Directly proportional. You should not say equal to. You should say directly proportional to the rate of change of momentum. Okay.
yes, sir.
Okay, that is good. What is definition of inertia, Kongwe?
Second,
Sir, inertia is the tendency of an object to remain at rest or continue in motion.
sir, did you tell anything else that is important that will come, sir?
No, we
No.
stopped there.
No.
When you left, we stopped. Okay. After that, the important points are the different examples of the inertia that we had seen. Okay.
Yes.
There are few examples,
sir.
around like 6 examples are present in your book. Okay, inertia of rest, and then for inertia of motion, there are 5
So
examples.
should we learn what is inertia of rest and inertia of motion?
Yeah.
Of
You have to
course.
learn.
Yada.
What you have to learn there. That is
So is
understood.
this, then it's at rest. It has the tendency to keep like stay at
Yeah.
like that's it. That's inertia of
Yes.
rest. And motion means
Unless an
tendency
uncle an external force is applied to it.
Yeah,
external
that
forces.
statement is important. Unless
So
and
for
until
both, for
force is
both
applied.
rest and motion.
Yeah, in both the cases.
Yes, sir.
Because even it can change the motion, na? You can change the state of motion by the application of force.
I'll double underline it, sir. That one line.
In science, we have each and every word of the definition important. If you miss that, you'll get the less marks. You are giving the invitation to the teacher so that they can cut your marks. Okay, so that is there. You have to be careful about it. Next is linear momentum. Okay, linear momentum is the product of mass and velocity, right?
Yes, sir.
If you have any doubt in any of the topics, just let me know. Okay, then we
Sir, can we
discuss
do
about the
this
rate of change.
one question?
Yeah, we will do the questions. Numericals will do. We are just discussing the theories. Okay, numericals will do in all the topics.
Oh, okay.
The rate of change of momentum is what? Mass times acceleration, right?
Yes,
Yes,
sir.
Then
sir.
we have Newton's second law of motion. You told the three graphs that I drew: acceleration, mass time,
Yes,
force,
sir.
mass, and acceleration, force.
Sir,
Three graphs are
I didn't understand one thing, sir. You remember you explaining us that when a smooth card is placed over that coin and it is like taken out.
What do you not understand in that?
No, like I didn't understand like what.
this
Like,
one.
I didn't understand the meaning of it.
This one.
Yes, sir. When it is taken, the coin, like it does not come out like.
The coin falls down, right?
Yes, sir.
So
Yes.
the thing is that what happens there is when you like, let us say, how shall I tell you? So let us say we have something like this. This is a box. Let us say this is the card. Okay, below this is the glass, and above this I am keeping this. Okay, right? This is
Yes, sir.
the hammer, or Thor's hammer.
The
I'm
video
able
is
to
so
pick it up.
small. Can't see.
I'm able to pick it up.
1 second, sir.
Sir, you're worthy enough, sir.
Now see,
Oh, yes, sir.
here, this has a tendency to remain at rest, right?
Yes,
Sir.
sir.
Agree?
Yes, sir.
If I move it slowly, what is happening? The lower part and the upper part of the body is taking enough time to move with the lower body. That is the box, right?
Yes, sir.
But if I
Yes,
move it
sir.
fastly, this is
It'll
here,
fall
We
and
down.
this
couldn't
falls
see what happened.
down. Exactly. See, this will fall down. This is here, this fell down.
Yes,
Understood?
sir.
Yes, sir.
Why
Yes,
did
sir.
that happen? So what happened there is that, see, when I took it really fastly, what happened? The lower part was a bit in contact and it understood the motion of the box. But this was so fast that by the time the upper part could understand the same thing, the box had gone. And it remained there for a millisecond, even less than that, nanosecond. Now what happened? Now nothing is there to provide the reaction. What is acting downwards? The gravity.
So
Gravity.
gravity.
This, it will fall down.
So sometimes it'll do a little flip if it's like too fast because the
That is
bottom
if
part.
the bottom object like has so much grip.
Yeah, that's what I'm saying.
Understood
Like
or not?
even you can do that in coin also. Take a full fast, you can like
It's
till
given
it fall down.
smooth card. Given yes, sir.
Smooth card, smooth card.
You understood or not?
Coin has ridges. Yes,
sir.
sir.
Yes, sir.
Okay. So all the three graphs you have to understand. Okay. What will the
Yes,
graph
sir.
of acceleration versus force if mass is
If
constant?
mass is
acceleration
constant, so it'll be uniformly drawn, sir. The mass
like this,
constant will be uniform. Like no, not like this, sir.
like
Not like
this.
this. Yeah, like that.
Sir, which graph, sir? Is this which chapter?
Acceleration,
This
force.
Which chapter?
second chapter. Second chapter.
Okay.
Mass is constant means it's like this only, sir.
Force is equals to mass times acceleration. So force
Yes,
is
sir.
active proportional to mass if acceleration is constant, and force is active proportional to acceleration if mass is constant, isn't it?
Yes, sir.
Yes, sir.
Okay. From there you can draw the graphs. And
but
one
if
more thing,
force is
if you have to
constant,
provide the force is constant, so acceleration will be force upon mass. So this will be inversely proportional. Graph will be hyperbola.
inversely proportional.
Acceleration, mass, for a constant force. Got it?
Yes, sir.
Yes, sir.
Okay, these things are there. Then define 1 Newton. Sankalp.
1 Newton is
Uh,
10 to the power 5
no.
dynes, sir.
Hey, no, you can't
No,
say that.
the statement.
The
So can I say?
Statement.
Can I say?
Yeah,
so can I
Nitish,
tell?
you say.
Can I
Sir,
tell?
Yes,
no,
sir.
I'll tell.
1
Sir.
Newton.
One. Okay, you tell. Sankar, are you
Nitish,
telling?
you say.
Yes, sir. 1 Newton is the force when is the force acted on a body of mass 1 kilogram. 1 kilogram produced an acceleration of 1 meter per second square.
Can you define it in a better way?
It is 10 to the power of
Sir.
5 dyne.
1 Newton is the no 1 Newton is the amount of force required to move a mass of 1 kg with an acceleration of 1 meter per second square.
Are correct. Okay,
Bro.
but write clearly. Both are correct. Write clearly. Right.
Yes,
So
sir.
1 Newton, one dyne is 10 to the power. Sorry, 1 Newton is 10 to the power 5 dyne. This you know. That's good.
1
Statement of the
So
second law.
I can write Cromwell's explanation, sir, because it sounds more confident.
You can write that. It was not confident. You could be confident if you say that perfectly. Okay, when your words are
you should
good,
like think
that
about
are
it
correct.
before.
Nobody can make it wrong. Next thing is that what is impulse? Sankalp,
What's
So
that?
what, sir?
what is impulse? Impulse.
Impulse, sir.
What is impulse?
What do impulse?
I don't.
Nintendo's impulse, sir.
Okay,
What
okay,
is
okay, okay.
impulse?
See. Impulse word is not there
Even
in your
even
book. That's
sir.
why I didn't do. See what is
It's not
impulse?
even there in the book, sir.
Yeah,
not
but just
there
you don't need to write this. You just remember this. Impulse is the product of force into time. And see why I asked you this. The thing is that this is a measure with which we consider while catching the ball in hand. How do you explain while catching we put our hands backwards? How do you explain that?
So uh,
So it is to
your
decrease the amount of force
Fingers
acting on our body. That is by decreasing the time, by increasing the time
time.
taken.
Okay, understood. So see,
Yes, sir.
in any collision, impulse is constant. Okay, so for that particular collision, if impulse for time, if you're increasing the time, so amount of force will decrease. For example, impulse is 12, so you can write 12 as 2 Newton force into 6 second time, or you can write 6 second force into 2 Newton time. Sorry, 6 Newton force into 2 second time.
Sir,
Yes,
what
sir.
is the unit for impulse?
I think
Impulse is
kilogram
force
meter per second
Newton
cube.
second.
Okay.
So
So
either
I
you
thought
can
it
provide
was
2 Newton force or into for 6 seconds, or you can provide 6 Newton force for 2 seconds. That means if you are decreasing the time, you're increasing the force, or if you're increasing the time, decreasing the force. So this is how,
indirectly proportional.
yeah, this is like related. But here in your book, they have like used this what shall I say that momentum term to explain the same thing. What they
Oh,
have said that final momentum is 0, initial momentum is mu, so final minus change in momentum is mu, right?
yes, sir.
Now what is force?
Yes, sir.
Force is change
The
in
force
momentum.
is yes, sir.
Momentum final minus momentum initial upon time, isn't it?
Change
Yes,
or
sir.
rate of change of momentum with respect to time.
Rate of change is
Yes.
constant. Even if you
Yes,
don't
sir.
pull that ball back, or if you pull that ball back, in both the cases mass of the ball and initial velocity of the ball is same.
Yes, sir.
So in both the cases momentum is constant. What is increasing? In first case the time is less where you're
Time
directly
is
catching it. In the second case the time is more, so if you increase the
more.
denominator, fraction will be less, hence force will be less. This is how they have
Yes,
explained
sir.
in your book, right? So you can write it this.
Yes, sir.
Okay. Then athlete often lands on sand or foam after taking a high jump. Why the sands or foams are
Same thing.
used?
So because
So
to
because it increases the time taken to land.
increases the time taken to
Yes.
decrease the force acted on the body. The
Because
same for
the
impulse,
sand goes a bit inside with the athlete, and that increases the time. Okay.
which
Yes, sir.
decreases the pressure or force.
Yeah.
Decreases the force. Yes,
Force.
Next.
force.
Pressure is with area.
Pressure. I mean, still same thing, but still. It's not the same thing, but it can also be an example.
Okay. Till here we have done. Then Newton's third law of motion statement. Pangwe.
I can tell.
Third law of motion.
Everyone knows, sir.
Okay.
Everyone knows that.
Sir, every action has an equal and opposite reaction.
Okay, every action has an equal and opposite reaction. That's correct.
Sir.
If action reaction forces are equal and opposite, so why do we consider that? Why can't we cancel them?
That's what happens, sir. They equal
So
and
because it
opposite,
is
so
in
we
the
cancel out
opposite
each other.
direction and no, No, because force is a vector quantity, so direction changes, and thus we can't cancel it.
I've
So what?
answered this question. Get your notes. I want to see that whether you have written this in your notes or not. Why can't we cancel like an action or reaction forces if they are
Sir,
equal
it's
and
because
opposite?
it's a vector. So because it's a
Sir,
vector
it's
quantity,
because
sir.
sir, it's because action and reaction forces acts on different surfaces.
Exactly.
Oh,
Exactly. I made you write this. See here. They may ask this
Yes,
question.
sir. Written.
oh my
If
God! You wrote it.
if we have kept a book here, so what is happening? Book is pushing the see in,
The table
if you
on
see
surface.
this part
The
in
table down.
detail, if you see this part in detail, so this is the book and this is the table. So book is pushing the table downwards.
And the table is
Book is
pushing the
pushing the
book
table
upwards. The
downwards
difference.
with the weight mg, and in return the table is pushing the book upwards with a force normal. In equilibrium
Yes,
condition, these both are equal.
M is the mg.
Okay, so this is action reaction force. This is the action. In this action, this is the reaction, but they act on different bodies. That's why we cannot cancel them, because they are actually acting there for different bodies. They are feeling that. If they would have been on the same body, for example, if this is my hand, I am acting 5 Newton force from here and 5 Newton force from here. How does it matter? It's going to cancel,
Yes, sir.
isn't it?
Yes, sir.
Yes, sir, because they act on different bodies. That's why we cannot cancel them, right? Okay,
I
then
did it
you
in my
Yes,
class.
sir.
then you be careful about the examples of the action reaction, rocket propulsion, motion of man on ground, all of them.
Like
You read that
pedaling
once.
in a boat.
Read it right in front of me. All of the examples right here. I
What,
think
sir?
one question will be there. Examples of action and reaction forces.
Yes, sir.
What should we do?
Sir, but in a normal reaction force, the action and reaction force cancels, sir.
Pardon?
No.
Pardon?
Just now said the reason.
Pardon? I cannot get it.
Sir, he said in a normal reaction force, the action and reaction cancels out.
See, see. When we consider the whole system, okay, you have to consider what system you're talking about. If you're talking about this whole system consisting of this book and the table, this is my system, then you will say that in this system a force upward is acting, a force downward is acting, both are equal, so they will cancel. Now I have shortened my system only includes this book. So if my system only includes this book, so I will only consider this normal reaction. I won't consider this because this is being acted on the table. Understood?
Yes.
So this depends on the system, what you're considering. This is apart from your level. So leave it. Still, I try to explain it to you. Okay, read all the examples. I'll ask you.
So what? What are we supposed to do?
Read all the examples.
In like the entire chapter.
No.
No.
Others,
Action and reaction.
action reaction examples.
Sir, I still don't understand that question you gave in the test, sir. That when the people alight the boat starts rowing away from the shore. That question.
Hey,
What's
Nitish,
the
it's because we push the boat, right? Like we push the boat like a bit backwards when we get up, right?
See, if this man has 1 feet on the ground and 1 feet on the boat, okay, and he's getting off. So what will happen when when he has to move forward? He will push the boat surface a little bit in this inclined direction, isn't it?
yes, sir.
And that has two components. That means if he's pushing something in the inclined direction, that means he's pushing back and downwards simultaneously, isn't it?
Yes, sir.
So downward force is balanced by the buoyancy, but backwards there is no friction in the opposite direction. That's why nothing is there to balance, and then the board goes away.
Oh, okay.
Understood?
Yes.
Read all the examples. Read all the examples. Try to remember it right now.
Third law, right, sir?
No, action. Yeah, okay.
Action reaction examples. Yeah, that is
Sir,
present.
there is a black screen in your.
Yes, so there's a black screen in
Sir,
the middle of your PowerPoint.
yes, sir.
What do you want to see? Like my screen or the sharing screen that I've shared?
No, sir.
The shared screen.
Sir, there is a black
your
screen
screen
in the
share,
middle of your PowerPoint, sir.
a black
Black-
box in the middle of your screen share.
Yeah, it's
And
gone,
now it's gone.
Everything we do has to. Oh, the book also is given the same thing you said. Sir.
Yeah, it's given the same thing.
You didn't know. What did you study there?
Hey, no, I put like the my logic of like that. The more the mass and inertia directly proportional mass. That thing I.
No, that is not good. Read it carefully first. Please don't talk. Read it carefully. Try to gain every.
So are you there?
Yes, sir.
I have a doubt. Like in the catching the ball thing, I think they have put in the same thing like when you when a ball comes. So I have a doubt.
While catching a ball, the ball exerts a force on the palm of cricketer, and the cricketer exerts an equal force on the ball to stop it.
So that means he's
What do you
pushing
have?
when the ball is coming like this,
No,
he's
da.
pushing his hand forward.
So the hand is a rigid support. The ball hits
Discuss.
the hand.
Discuss your own. Is there any
Yes,
doubt?
sir.
So I'm done, sir.
So okay, nothing. I have a doubt with the catching a ball that last one.
What doubt?
So like when the ball is coming to his palm, is it like pushing his hand forward for to compensate with the ball's action, or is he pulling the hand backwards?
What do? You must have played
I
cricket.
pull my hand, but in the book.
That is there. So you answered yourself.
Sir, we do it like that because like when we like keep the hand like this and not move our hand backwards, it like our hand will stay in the rest and it will like the ball will be in motion and when it touches our hand it will like I don't know like we
Either
get hurt.
recoil our
But when
hand
it
or
is
either
in
bounce our
but
hand.
when it is in motion, like according to inertia of motion, we won't get any hurt. Like, is that also
No,
an
no, no.
explanation?
Thing is that no. Don't mix up 2-3 things. If you are just keeping your hands like this, so what is happening? The ball is instantly stopping here. Okay, instant
Ball is
stopping,
bouncing
less
up.
time, more force.
Yes, sir.
Okay, see, let us say initial momentum of the ball was 10. Finally, it is 0. So what is the change? Changes of 10,
And
and you're like stopping it in 1 second. So what is the force? 10 by 1.
10 by 1.
Okay.
Yes,
Now
sir.
in the second case, what you are doing? Initial momentum is again the same 10. You took it and you like while taking it, you took it a
Gradually
bit
stop it.
backwards. While taking it, you took a bit backwards like this. So what happened?
10/3 or something.
Again, the change was from 10 to 0. Change was same, but you took 2 seconds, let us say. So what will the force? The change is 10 divided by 2, that is 1. So you reduce the force now. So that is what you do. No inertia. You don't have to include inertia there.
Yes, sir.
So I finished reading and then.
Yes, well,
Okay.
sir.
Yes.
So how does rocket moves upwards? We just now saw a rocket.
It
Sir,
pushes
then
the
how do
gas
we
and
explain
moves.
that? How do we explain that catching a moving bus thing? Should we explain it in the time one, or should we explain it in inertia of motion?
No, that is different. You have to learn that now. Where you have to include what. So that catching a bus, you have to jump while coming off from a running bus, or you get a jerk while the bus starts. So that is due to inertia. So from
Yes,
there,
sir.
that you have to explain with the inertial like expressions. Here, this is something else. So you have to be clear about it. That's why I asked you to read 3, 4 more times to check whether which one of the example has to be explained by what concept. Okay. Now the third thing, that is gravity.
In the rocket motion thing, if the nozzle is not like that thin thing, and if it's the nozzle is wider, the force of the gases will be less because the area of the thing will be less, right? So
Yeah.
that's why the
Yeah.
nozzle.
Yeah, it's
No, see,
similar
the
in
thing
like
is that
hydraulic press.
this you don't know. This you don't know. The thing is that when the pressure is more, we study this in your fluid mechanics. We'll study there. Okay. When the pressure is more, your velocity is less. You don't know. Have you ever heard that don't stand near the train, passing by train, otherwise you'll get attracted towards it and then you'll fall into the train and then you'll meet an accident in the
What?
railway station?
No, sir.
Yes,
Have you ever heard
actually,
that?
there
Your
will be
father
a
and mother
line.
must have told you
There will be
that
a
don't go
line.
towards the train. You
No,
must have
sir.
argued them that I am at a safer distance. I am at a distance of 2 feet. I won't be touching anything. So how would I be getting attracted to it?
That yellow
So
line.
the pressure, that air pressure is
Exactly.
going
See what is
around the.
happening there.
I
What
thought
is
like
happening there?
you will get away from the train when the train comes in a very high speed, because the
No, no, no,
train will
no.
pierce
If
through
you're
the
standing
air.
here, if you're standing here, and when this train is moving by with high speed, let us say 100 km/h. Okay, so what will happen? The air just with the side of it, the air right here, air. Okay, even that will be in the same motion. That will be in the same motion. Agree?
Yes,
Yes,
sir.
sir.
Agree? So
Yes, sir.
if the motion is really high, velocity is very high of the air, so pressure is inversely proportional to velocity. Okay.
Yes.
If velocity is very high, so pressure will be very low. If velocity is high, pressure will be low. And you know how do you travel? You travel from high pressure to low pressure. High pressure to low pressure. This is the movement of air. You must have
Yes.
heard that low pressure zones are created on India. That's why we are having heavy rainfall, isn't it?
Yes, sir.
Because what happens
Yes,
wherever
sir.
the high pressure is, wherever around India the high pressure is, the clouds travel from high pressure to the low pressure zone. Okay, and then they pour the rain. So that's why what
Yes.
will happen, if the low pressure zone is there between you and the train, you will get stick to the train. Got it? So there is a scientific explanation. Even I used to argue much with my parents that if I am standing at a safer distance, that is 2, 3 feet away from the train, and I'm not touching anything of it, so how will I get attracted towards it?
Oh, even like when it's going very high speed, like that maglev train and all, will start flying backwards, right?
Like
Because
bullet
of the
train.
air pressure. When it goes like this, we'll start having a pressure like from backwards.
Help, are you
If
having a
it's
jungle
so
safari?
fast, you can just stand next to the train to go to the destination.
I think Sankalp is having a jungle safari.
That
So long
means
he's
this
been
location
walking.
itself.
Sir, he's
Let us see
outside,
that
sir.
Animal
Having
Planet
fun
here.
in resort.
Oh,
I have my own go to resort until it's monsoon days. So,
Okay. So all these things are define me gravitational constant. Who will define gravitational constant?
sir, me, sir, I will do it, sir. I close my book. It's on my head, sir.
Me, no.
Sorry, sir.
Basic.
I asked
Go on.
first. Sir, gravitational
Sankar
Guys,
constant
tell
walked
is
us
all the
something.
way.
numerically. The gravitational constant is numerically equal to the force. I mean, to the magnitude of force acted on a mass, acted on two masses of 1 kilogram, kept at a separation of 1 meter. Kept at
Congo,
a
you
separation
tell.
of 1 meter.
Yes, sir. Newton's gravitational constant is 6.67 into 10 raised to the negative 11, and its definition is it is the force required. It's a gravitational force acting.
Mine was better. I think it's net con.
Your answer is correct. Your answer is correct. Just you need to
Yeah.
like, revise more. Be confident with your answer. I need that in a single line, single shot. Okay. Try to revise more.
Yes, sir.
Congo, we cannot hear you.
So they will. So from the test we wrote now, I am so sure that ma'am will ask all the definition questions with the numerical form also, sir. Ma'am asking
That's why
Hello, sir.
that's why we are discussing it now. That's why we are discussing it now.
Hello, sir.
exactly what is
Yeah, Congo,
Yes, I got disconnected.
cannot hear you.
Okay, sir. Newton's gravitational constant is the gravitational force of attraction between two bodies of mass 1 kg each, separated at a distance of 1 meter.
Understood, Nitish?
numerically
I want
equal.
answers like this. Answers should be this way. Sankalp, understood?
Sir?
Answer should be this way. Very in a neat manner. You have to write everything. If you revise, I think you have revised. You all have revised. I don't know about Sankalp because he is not answering the force. He is telling that he has revised magnetism. We'll discuss about that also.
Sir, I
So the
did
thing
only
is-
magnetism and
okay, no problem, no problem. We still have time. Your exams are on 17th now.
Yes,
Exams
sir.
are on
Two more days,
17th.
sir.
So I think
Monday.
you have revised a bit, but I think you need 20% more revision. Okay, 20% more revisions. Get cleared concepts about the physics. Okay, I don't think you have any doubt over any of the topic. Do you?
No, sir. So maybe I have
No,
some
sir.
doubts in
I just
magnetism,
want
but
to do so much
Okay, we'll discuss that.
numericals.
We'll discuss that. Numericals we
Sir.
do. Okay, so this is there. We
it
have
is
discussed.
fine.
Okay, we have discussed this. Okay, one more thing is there. The characteristics of gravitational forces between two masses. Who will tell?
Yes,
Three characteristics.
can I tell?
Okay,
If
one
no
of
one
each you
can
tell.
tell.
One of each you tell.
Okay, I tell one. It is always
What?
attractive. Now, Ponguvel or Sagankal, any one of you tell one.
Kongwe,
Wait, sir, I don't know this.
check there's the last topic.
Can you repeat the question? Can you repeat the
What are
question?
the
Yeah.
characteristics?
Gravitational forces. Nitish, tell the second point.
Yes, sir. It
So
is
it is
indirectly proportional to the distance.
Yeah, square of
Indirectly
distance.
proportional
square
to
of distance. Square of
square of
distance.
distance. My bad.
Square
Yes,
of
sir.
distance. Sankal,
I
third
remember. I
point.
remember. I didn't hear it
Yes,
properly,
sir.
sir.
Tell da. He asked you da. He asked you a question da.
What, sir?
Characteristic. Any
Third
one
point of the
characteristic.
characteristics.
Gravitational constant. What is
Search
the
fast. Search
characteristic?
fast. Open the book. Sir, he's seeing from the book, sir. Look at the
Yes, sir, I
camera.
am,
Look
sir.
into my eyes.
There's only he showed inversely
Look at
proportional
my
to
eyes.
square of
No, there are only
not
2
the-
points, right, sir?
Hey, this is a four da.
There's 4.
Sir asked only
There's
three.
4. Okay, Nitish, tell third one. I'll tell
It is
fourth one.
You already said third one. Okay, it's second one. It's directly proportional to the mass. And come with
Yes, sir.
John.
It is. Uh,
I can tell the fourth point also.
No, no,
I'll tell
not
the
like
fourth
that.
point.
hello, sir. Can you
Not like that. Not like that. You already
can I
told,
tell-
can
na?
you see
Okay.
my video?
Oh, okay. No one is telling.
Uh,
So.
I'll tell. It is.
Tell
Sir, I'll tell. It is significant between the heavenly bodies, but
Yeah,
is insignificant between normal bodies because
exactly.
of
Good.
Of G.
small magnitude.
No,
Right.
because of the low values of G, big G. Stop.
Dog G.
Okay, we have a question.
Numerical?
Yeah, we have two
Oh.
bodies. Two bodies,
1 second, sir. I'll take my pencil. Oh.
Oh,
mass m and 2m.
two bodies of
M and
mass
2m.
M and 2M.
Sir, of mass?
M
M
and
and
2m.
2M.
M and 2M.
And velocities v and 2v respectively.
Respectively,
Okay.
in the sense 2V is final and V is initial.
Oh, let it be 2v
No,
and
no.
v. 2v and v respectively.
Okay.
Two
Respectively
bodies.
means
First body has got mass m, second body 2m. First body has got velocity 2v,
oh,
second body 2. Okay. You have to calculate ratio of their inertia. Second, you have to calculate ratio of their momentum. Third, you have to calculate force needed to stop them.
how am I supposed to find the ratio of inertia, sir?
Got it.
You can,
I've discussed about it. You can turn your pages of the like notes. Don't read notes, but I'm very much. I should be angry, but I'm not. Why don't you read the note?
done, sir.
Everyone?
No, sir, no, sir.
1 second, sir.
Okay. Um,
Sir, can I tell the answer?
Yeah,
I
Thomas, go
also
on.
found the answer, sir.
Yes, sir.
I also
Yes,
found
sir.
the answer, sir.
Okay, sir. Okay, I'll tell first
I
one.
got second. I got second. I'll tell second.
Go on.
Sir, first one is 1:2. Second one is 1:1, and the third one is also 1:1.
Nitish?
So for me, the first one is for me the first one is 1:2 only.
1:2?
2.
2.
Yeah.
Second?
Second one for me it is 2:1.
Third?
Third one is 1:1.
Sankalp?
So 1:2, 1:1, 1:1, sir.
Same
I'm
answer
Yeah.
as me, basically.
This is correct. See, ratio of the inertia. Inertia is a measure of mass. I already told you.
Yes, sir.
Inertia is the measure of mass. Greater the mass, greater the
Velocity
inertia.
doesn't play a role.
Exactly.
That
Second,
one I
take
got
ratio of that momentum. So first momentum is mass into 2 velocity.
Mass into
M into
velocity.
2v.
V
And
equals
second is
mv,
momentum into
so
v.
2m 2v.
So 2 MV by
Same
2
thing,
MV, same thing.
Sir.
Same thing only. What is
Yeah,
this
Third is
implementation?
force needed to stop them. So if time is not given, you have to consider the same time they are taking. So first is m into 2v is getting this is the initial momentum. Final momentum is 0 because it is getting to be stopped. Let us say this happened at time t. So what will be force? Force will be 0 minus 2mv upon t. So that will be 2mv upon t. Let us consider only the like magnitude. Minus and will give you the direction. Second is
Sir,
getting 2
I
to be 0. So force will be what? 0 minus 2mv, again the same thing, upon t, that is 2mv upon t. So force in both the cases will be same. So that's why 1 is to 1. Isn't it?
so I have a small
Wait,
doubt.
wait.
Go on.
I have a small doubt. For the first one, ratio of inertia. What if it's ratio of inertia of motion? So it'll be same, right? Then 1:1, right?
Whatever it
Because it
be,
is
inertia is a
moving
measure of mass.
and velocity plays a role right there.
Question is,
But it's going faster, right?
see, we are just talking about the inertia. Inertia is basically dependent on the mass, irrespective of the motion. Okay, we consider it to be at rest. Then only
Okay.
the motion should be same. If you want to measure two inertias, inertia of two different bodies, so the like, what shall I say, that motion should be same. Then only you'll be able to
So
compare.
I'm talking about inertia of motion, sir. Inertia of motion.
See, there are whatever inertia it is. For example, if you say that 10 meter per second, with 10 meter per second an ant is moving, and with 1 meter per second an elephant is moving, which one will you be able to stop? Which one
10
has
meter
more
per
inertia?
second and
Beyond.
Just per second. And
hey,
Okay.
yeah,
It has
easy
a greater
stuff.
inertia.
10 meters per second doesn't matter though, because it's inertia is a measure of mass.
Exactly.
Oh,
Greater the mass, greater the inertia.
sir.
Okay.
so 1 meter per second is still so fast. 10 meter per second is like bullet speed.
Bullet speed is more than 300 meter per second.
Oh,
300. Sir,
100,
Sir,
150,
can
300,
cross
like that it will.
can cross my
almost a
entire
fast
street
as
in 10
mine.
seconds.
Almost
Wait,
the
not
speed
10,
of the
like 2 seconds.
Pankaj brain power.
Brain power.
Next question.
As fast.
You mean IQ?
Right there, right there, right there, right there. Write a question.
Why
A
do
force
you-
acts for 10 seconds on a stationary body. Question.
So what's the question?
A force acts on a stationary body for 10 seconds. Okay.
Yes, sir.
Having a mass of 100 kgs.
I don't want decimals to come.
After this time, force ceases to act. Okay.
So force becomes 0.
The body moves through a distance of, don't mind my handwriting, distance of
Yes, we can.
100 meter in next 5 seconds. First, because what has happened that I have just got hurt in my hand. I'm not able to write properly. Calculate
How, sir?
In the sense, after the 10
like
seconds,
that. Where after 10 seconds having a mass of 100 kgs, after this time force ceases to act, the body moves through a distance of 100 meter in next 5 seconds. Okay, you have to calculate. Velocity, calculate acceleration, and calculate force.
literally this is some already.
Do this.
So what, sir? You let's stop the thing, sir. What at all should we talk?
Pardon?
Acceleration. Nothing, sir.
The body moves.
Hello,
moves-
sir. Am I audible?
Yeah.
Even the singing in the background is very audible. So what's the second one?
Acceleration, force, velocity.
Oh,
The
acceleration. Okay, okay.
velocity of what, sir? Like the first 10 seconds or the full 10?
Sir, I'm done.
Sir, can you see me, sir?
Velocity.
Sir, tell us, Pugul, is it like velocity
What?
for first 10 seconds or like last 5 seconds or the whole thing?
Hey, for the next 5 seconds. Sir,
Sir,
oh my god.
See the screen?
sir, I'm also done, sir.
Can you see the screen?
So we can't see
Okay.
the screen. No, sir.
No, sir, I can't see the screen.
Sir,
One
I
minute, I
also
don't.
finished.
Sir, I can't see the screen, sir.
I'm
Minute, I'm
Yeah,
finished
just.
now I
now.
can.
Oh wait, it came.
No.
Undefined learning room is sharing the screen now.
I don't know what is happening here. I'm just getting out of the meeting.
We can see. We can see.
Yeah, now
We
I
can
can
see
see,
now.
sir.
Solve this, all of the three.
I'm finished, sir.
Sir, can I tell the answer?
Even I
Okay,
finished
that's
now. I said I'm
So 1 second, sir. One
Okay,
second.
we'll
I'm in
wait
the
for
last.
Sankar.
I will. Sankalp, Sankalp. Shut up. Dun, 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 dun.
That was nice.
Why?
So I'm telling first because Coconut is cultural. Good fellow.
Okay, boss.
Today was so fun. That's good.
I know because Uncle was absent.
No, no, sir, that was not the reason. That was not the reason. Sir, don't get that.
So we didn't have a single we didn't study a single period today. It was all free period
Okay. And
except
shall we
for
do?
second
Once,
language.
for
Okay.
once, my
Yes,
French
sir.
teacher gives me games, and I had to be absent on that day, sir.
No, they
Sir,
didn't.
sir, me first,
Okay.
sir.
Okay, Nitish first. Please
Yes,
tell
sir.
the
Power
Can I
answer.
help?
Nitish.
Sir, the velocity is 20 meter per second.
Okay, okay.
And the acceleration is 2 meter per second square.
Then,
And the magnitude of force is 200 newtons.
okay. Pangwe,
Wait. Oh, yeah.
Same answer, sir.
Sankalp.
Yes, sir.
Sir, are you there? Oh, again. No. Again, something happened.
Wait
to
a
you,
second.
sir.
I think I made a mistake.
No, I'm 100% sure I made it wrong. So you're also wrong.
1 second, sir. Please.
You stuck. Even I made it wrong. Well, it's not that. It's just something happened. I think.
I'm here. I'm here.
Oh wait, it's correct. It's correct.
So
It's
then
correct.
why
My
did it
bad. It's
suddenly
correct.
become silent, sir?
Yes, sir.
Sir, it's correct. Sir. Nothing problem.
So why did it suddenly become so quiet, sir?
I know.
Help your answer.
You already said.
Said same a
Sangal.
long time ago, sir.
That's correct.
So he said the same.
Da-da-da-da-da-da.
Okay. So I hope you have done it correctly. Okay.
Yes,
Sir.
sir.
So
Sir, you said
I'm giving you 5 minutes break. You can.
break.
Yes,
No,
sir.
sir. I need
Just
a
go drink
break.
water.
I'll go there and then I'll come back.
And then just after 5 minutes, okay, right after 5 minutes, I'll be here. I'm not ending the meeting. You don't have to end the meeting. You can just put your mics off and then.
Sir, we usually
Yes,
won't
sir.
have a break between classes, sir. So anyway, you can continue.
If you don't want, we can continue. If you want,
Sir, it's fine. We'll have a break.
Nitish, you're mute.
If you want, you can teach Sankalp, sir.
Dead
No
among
objection.
himself.
sir.
Okay, I'm just coming in 2 minutes. You can come in 5 minutes.
Yes, sir. Yes, uncle. Today was so fun, da. Unmute and speak. Oh. You know, we played hand cricket world. No, wait, hand football World Cup. Hello.
What? Hey, I
We
don't
played
want to
hand
talk
football
about
World
today.
Cup. Actually,
Hey,
we didn't have a
Pankaj, today
single
was so
class.
fun, lah. We played
Hey,
hand
cricket,
football.
hand football World Cup.
We had World Cup, da. Hey, Croatia and Portugal, da. Konguvel. You versus
Yeah, I
Croatia.
know. Service told.
We lost. I lost.
Mhm.
I went to semi-finals, sir, uncle.
How do you play hand football?
We'll teach you. We'll teach
Very
you. It's
secret.
so fun.
Later, I know.
We can't. Now we're not
Finals
gonna play.
is between me and Sarvesh.
Croatia versus Portugal. Croatia versus Portugal. The only field we did
It's
work
so
is
fun, da.
biology.
Yeah, da. Hey, by the way, French ma'am didn't give games.
Yeah, they gave game.
They
All of
didn't.
you are back.
Hey, they all went down. Yes, sir. Yeah, I came back, sir.
Okay. So next question says that
Next question. So I did 20 questions in my own, sir. Are you proud of myself?
Only 20.
question is like a
The question
car.
is like
20
he'll
by
just
today, da,
calculate it.
from when I came back to now. That's impressive.
How easy of questions did you do, da?
Hey,
With the
every
velocity
question was 700 pages long. Da. A car is
30 meter per second. It is stopped.
it is stop. Okay.
Stopped
I already know the answer.
in 2
Stop.
seconds by
So this is the
force of
direct question.
1500 Newton.
A strong man.
Calculate change in momentum.
Ah,
Second, retardation produced.
so to find the change moment, I just have to find the mass.
Pardon?
I have
So,
to find the mass
a
for the
third one
change in
is
moment.
mass. Basically, everything we can find with this data.
Mass of the car is also what you have to
Retardation produced
calculate.
in the car. That comes out 5.
The change in
also-
momentum is the change in momentum is force, right, sir? Then like
Change in
Change in
momentum.
momentum
Well,
with
time
respect
is
to
force.
time is only force. I'm so
What is Sangal?
Just solve this.
no, not my uncle. It's 2 days before exam.
Very bad Sangal.
What's the third one? Mass of car. Sir, we need to find mass of car to find change
Yeah.
in momentum. Sir, why did you not give the
we
third
need to-
one first and then first one third, sir?
Pardon.
Why did you not give the first one and the third one and the first and first one and third, sir? That's how it's okay. Nothing, sir. I take
Same
my
thing
back.
it is. Same thing it is.
That's a big clue you gave.
Sorry, sir. What? Like, sir, for example, this is not in the thing. If I have like
Yeah.
20,000 divided by 20,000 only, no, sir. No, not 1,000.
Nothing, sir.
So, okay, nothing. So, like, I have 17,000. Divided by 17, I'll get 100 only, no, sir. Not 100.
No, you get 1000.
Okay, thank you.
Sir. Hey, Satish. Yes.
So one second,
You have to
I'm
do it in
done.
the answer, sir.
Yeah.
No, wait. One second.
Done.
Wait, no, sir. Have back on
I
with.
am done. I am done. I am done.
Yeah, wait.
Sir, done, sir.
Sir, sir, I did second and third. Sir. I did the first one. Yes, sir. One second.
Okay.
Yes, sir.
You want to see my book?
Sir, one second. Sir, almost done, sir.
Sir,
This
what
Sir,
is
is
that?
that
Is that your college
Yes.
book?
is that ninth?
No,
Nine.
this is my book.
Okay.
No, sir. One more second. Sir. Zero, 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 zero,
Sir, that is the thing is 2 times bigger than our maths textbook.
zero.
No.
And
Yeah.
I think
1.5.
I have 10 of that.
Wait.
That much are 10.
So what course are you studying?
Civil
Yes,
engineering.
I think I am wrong about the.
Oh.
So I'm finished, but I'm pretty sure I'm
Okay,
wrong
we'll discuss now. We'll discuss now. Pangwe, tell the answer.
Okay. Sir, minus 300 kilogram meter per second.
minus 300 kilogram meter per second.
3,000.
Then
Sir, my bad. 3,000. 3,000.
Okay.
3,000. Second one is 15 meter per second square. And the third one is 100 kg, sir.
never forget to write the units. You are writing that. I'm happy for it. Sankalp,
Same, sir.
same. Nitish,
Same,
Average
sir.
uncle.
good.
Sir,
All of you are correct.
sir, you said
Okay,
60.
two things I want to ask. Before your doubt, Nitish. Two things I want to ask. If instead of retardation, I would have written acceleration produced in the car, what is
Minus
the what?
15.
Sir, negative 15.
Minus,
Very good.
Minus 15.
minus
Very good.
15 meter per second. Right?
Minus.
Tarun joined like half of the class later.
They went to
Hi,
football match.
Tarun.
Hello, sir. Hello, sir.
Doesn't make a difference. Hi, Da.
Sir, I have a single.
Sir left after Tarun joined. Tarun, nobody likes you.
I mean,
Sir, Tarun joined and you left, sir.
I saw that. Okay. Second thing. Can you
Sad
find
Tarun.
the initial momentum here and final momentum? Your final momentum is
Sir,
zero.
it's zero.
Initial momentum.
No. Initial momentum is only three. Initial momentum is 3,000 kilogram. 3,000. No, 3,000 kilogram meter per second.
That's correct. That's correct.
Sir, we have a guest.
Just without the minus. Without the minus.
Yes.
Tarun came and left. Sir.
Hi, guest.
Tarun physically present, mentally absent. Sir. Sir, mentally present, physically absent. Sir.
So happy. Why are you so happy,
Tarun
Da?
thought that, sir. Look at his face.
Okay, write the next question.
He's a guest.
He lost the first round itself.
Next question.
So,
Next question says that
Days.
a bullet mass 50 gram moving with a velocity of 100 meter per second strikes a wooden plank. and comes to rest after penetrating
No, I hate decimal kilograms.
2 centimeter in it. Work with that, you'll get fine with it. Calculate initial momentum.
Sir, but according to Newton's third law, when it strikes the wooden plank, either the wooden plank should go back or the ball should bounce back. So it can't come to rest, sir.
Depends upon the
Immediately.
rigidity.
There
What?
is
Hey,
negative
that's not it.
acceleration there.
The wooden plank is very rigid. The ball is bound. Oh, bullet. Okay, sorry, sir. The bullet will break the plank and go, sir.
Acceleration
Penetrating.
caused
Penetrating. What did
by
you write, sir?
where penetrating 2 centimeter. Acceleration
So-
caused by wooden plank.
Initial momentum. Okay.
Fourth.
Sir, am I audible?
Yeah, you're audible.
Yes.
Sir, I don't know why everybody's video is just stuck for me, but I can hear you.
Pardon?
I think it's your brain problem that's already.
Everybody? I could not hear.
Everybody's video is stuck, but I can hear you guys and see the screen set.
Okay, no problem. Sometimes it happens. Try to solve this question, everyone.
Yes, sir.
They are one of the most probable questions that can come in your
This
exam.
is so easy, the first two at least, not the last two. But
I don't think they'll ask this hard, sir.
No, they won't.
they won't even ask anything that stops. How is it hard? It looks pretty easy to apply to Diego. Oh, wait, I just now realized you didn't give time. Bro.
That's not required actually. Wait, it actually is.
No,
But
no,
probably not.
there is a formula. I think you know what I'm talking about.
Second chapter.
Third, oh, I mean, yeah, from the second chapter, but third question, acceleration. So what is 10 square?
100.
Pardon?
What are you talking about?
100 square?
10,000.
Thank you.
10 square is 100 now.
Yeah,
Oh,
sir,
yeah.
that I know, sir.
Am I a calculator?
That I know, sir. Like silver psychology, sir. If I directly ask what I'm asking for, you won't tell, sir.
I will tell.
Okay.
I'm not that dumb.
Wait a minute. How am I supposed to find? Okay, yeah, I understand. Nothing, sir.
Average is this. Nothing, sir. Sir, but I'm nothing, sir. So the thing is nothing, sir.
Not
What
you,
happened?
sorry. Nothing, sir. Nothing. Eh?
Nothing, sir. Second.
Hey, என்னப்பா?
Why are you laughing?
Nothing, sir.
Nitish is audio.
I heard that, but still it's not a matter to laugh.
How do you find the time, sir?
Look at your clock.
I didn't ask that.
12, 16, 20. 0. Oh my god, 0. Oh my god, 0. 500. Oh my god. I found this acceleration or no.
You just
Why
said
is
the answer, huh?
Nitish,
why what?
my mom is laughing for your dumbness there.
What did I oh she heard my time joke.
What?
She heard my time joke.
Try to solve the question.
So why
Yes, sir. Stop distracting
why
me.
my sister turned off my fan and pressed it. 1 second. Oh wait, 1 second. This is the force exerted by wooden plank.
So should we write like retardation of the wooden?
Could not hear that.
Oh,
Say that again.
Sir, should we write like retardation of
That's a
wooden block?
big acceleration.
We have to find reacceleration.
Oh, sir, what? I'm not hearing you.
Acceleration caused by the wooden plank. That we have to find.
Yeah, yes.
That's a lot of acceleration.
I'm pretty sure.
Done? You're taking too much time.
Yes, sir. I'm done. I'm done long back.
How do you do it, sir? Like,
I'm almost done, sir. Like a last step, sir.
sir, it's like if you, when you need acceleration, you need force, but when you need like how?
I found out. I was the last step. Yes.
The answer.
Victory! I am finished. I finished, sir.
Tarun, shall we wait for you?
Victory round.
Sir, no, sir, you can proceed.
Okay, now see here, everyone.
Wait, sir. Me and Kongo will tell our answers, sir.
Sankalp, see here.
Yes, sir.
Okay, first let us take the answers. Yeah, Congo, your answers.
Sir, first one, 5. Let Nitish tell. No, I want to tell. Okay, I'll tell. I'll tell. First one is 5 kilogram meter per second.
Okay.
Hmm.
Second one is 0.
Third one.
So you don't have to write unit for 0, right?
No.
Hey, you should. Kilogram meter per second. No.
Sir, next one
You may write
is
it.
yes, sir. Next one is minus 250,000 meter per second square. I don't think it's correct.
Yeah, even I got
250,000 is this.
Another 0.
Even I got the answer.
Correct, sir. It's the same. Next one, one 12,500 newtons.
same, sir.
Same.
Sir, yes, sir.
Okay, correct. Tarun, same.
Yes,
Sir,
sir,
like
yes,
this,
sir.
Arun explain it, sir.
Okay, now see,
Same,
I'll
sir.
explain here. Initial
12,500
momentum.
Nitish.
The momentum, how is momentum is calculated? MeV into V. What is mass? 50 grams. 50 upon 1000 is kg. You have to convert it into SI unit. Please be quiet when I'm speaking. Now you have to multiply it with velocity. Okay, you get what? 5 kg meter per second. Right, Sankalp?
Yay!
Okay, now final momentum. So if it is coming to rest, that means final velocity is 0. Final velocity is 0. So final momentum is 0, isn't it? Whatever mass it may have. Understood till here? Acceleration caused by wooden plank. So see here, there's an equation called v square is equals to u square plus 2as. V
Yes,
square is equals
oh,
to u square plus 2as. So
Yeah,
finally
this is
it
what I
has to
use.
stop. Finally it has to stop.
No.
Initially, what was the initial velocity? Initial velocity was 100 meter per second.
Oh,
Okay.
yeah, okay. Sorry.
And then that is to be squared. Then 2 times acceleration we don't know, and the distance it took before stopping is 2 centimeters. That means 0.02 meters. Okay. So 0 is equals to 100 square plus 2 into acceleration into 0.02. If you calculate acceleration from here, you'll get 100 square up minus 100 square upon 2 into 0.02. You get it as how much? 25,000. Sorry, 2,50,000 around. Newton, so meter per second square.
Oh, correct.
Acceleration
I was
and find the
confident about
resistive
this.
force. What is resistive force? So force is mass times
F
acceleration.
equals ma.
The mass is 50,000
0.50.
1, 2, 3, 4 equals 125,000 Newton. Understood everything or not, Sankalp?
Yes,
Yes,
sir.
Okay, I want the answers from you from next time. Okay,
Yes,
this
sir.
we have done. This we have done. Let us move on to magnetism now. All of you are
Sir,
done.
sir, I didn't do it by. Sir, but I
Sir,
didn't
can
do
we
it.
do?
Sir, but I didn't do this step like 50 divided by 1000 into 25.
How did you
You
do that?
took 0.05 only. No, you can do
Sir,
that also. I
From,
I
from
got.
final moment.
Use the Google method.
Come on, let me see first. No, you cannot say like that. Let me see
Hey,
first.
okay. Sir, I use b square minus u square
Hmm.
equals to a.
Yes, from there you will be calculating acceleration now.
Yes, sir. That's what you
So-
calculated.
No, we have to calculate force after that. Acceleration we did.
Oh, okay. I got that.
Sankalp,
Force we
hey,
did.
Tarun. Sir, 1 second, sir. Tarun, look into my eyes. Take the book, the textbook in your hand. Show it in the camera and tell what.
That-
Not the
No,
textbook. No, sir. I'm asking one question.
No,
Tell
please
what's
be
the
quiet.
statement for second law
Please
of
be
motion.
quiet. Please be quiet. Open all of your books with magnetism.
Sir, can we do the second chapter because it's harder than the last one?
We have to revise the magnetism. Akana. No need, Tarun. I believe you.
No,
It
sir.
should not be like
I'm
this.
not asking this one, sir. This question, I know he did it. I'm asking what's the statement of second law of motion.
No. It should not be like
He's
this.
turning his pages.
Believe
Oh
your
my
friends.
god.
Okay, next thing. See here.
Sir, please.
So what is doing that?
Open your book, magnetism.
Yes, sir. I opened
Yes,
it.
sir.
Sir, can we do chapter 2 because it's harder and I have some doubts in it?
Sir, which one?
Chapter 2, motion in one
Motion in
dimension.
Yes, sir.
Once we discuss
No
it, we
need
can
to-
go back to that particular.
No, let's do let's do the second
Yeah,
chapter,
magnetism
sir.
said this too. For me, this is the
It's
toughest
easy,
chapter.
sir. Magnetism is easy.
Let's do motion in one dimension. Magnetism is easy.
Only
I wanna do
theoretical.
magnetism.
So you remember all the like. Can you just have a quick revision of yours if you want?
Yes,
sir.
sir.
We can do that. Quick revision.
Yes.
Oh, so I forgot to remember.
We took
memorize
very
that
less notes for magnetism, sir.
because we were rushing. Rushing.
Sorry.
Only
Tired.
wrote 2 pages.
I didn't write
No,
anything.
3. No, wait, I wrote.
Actually, I wanted you to study the notes from your book because if I went on to write the notes, so it would be taking me more than 3 to 4 classes to complete it.
Yes,
Can
sir.
you send me the physics classwork after this thing ends?
Yeah,
So-
I thought you took my class today only. Okay, I'll
That's
send you.
why that's why we did not do this.
Oh,
Okay.
yes, I'll
I'll be asking questions. You need to answer. If I get that you have remembered it, then I'll be leaving this chapter. Now Nitish will tell me the definition of magnetic field lines.
Sir, it's the magnetic field lines. Okay, it is the continuous curve in a magnetic field such that the tangent of at any point of the magnetic field will show the direction of the field line.
All of you open your camera. That's correct. That's correct.
I studied this so hard. Nice, thank you. Just from the bottom.
Yeah, yes, sir. I didn't hear the question, sir. Can you repeat it?
What is
Okay.
what was magnetic field? Yeah.
Your cell.
Okay. Okay.
Okay.
Next thing,
Wait, why is it tiles for me?
what is magnetic
You
equator?
can change it.
Uncle, what is magnetic
So
equator?
what?
Magnetic equator.
Did we learn something like that?
Yeah, we learned.
Did we
I
learn?
remember. I remember. So if no one can
Even
answer, I
Nitish?
can answer.
Yeah. Go on, Nitish.
Sir, line joining the places where the magnetic needle becomes vertical is called magnetic field. I swear.
No, no, that is the poles. Horizontal. See here.
Oh, okay.
Magnetic
I
field
understand.
comes from here and then it goes like this from here to here. So near the equator, this is the equator, magnetic equator. Near the equator, you see that magnetic field lines becomes horizontal from all the sides. Even from this side, it becomes horizontal.
Yes, sir.
You can see the screen now.
It's not vertical, right?
Yes, sir.
So we
It's
can
not
see the
vertical.
screen.
It's horizontal. It's horizontal. See there. It's horizontal near the equator. It's horizontal.
Oh,
Okay. Vertical is near the poles. Vertical is near the poles.
Oh, yes. Sir.
Okay. Write it down there, everybody. Next,
I
you.
even I don't
I
remember much
didn't
of
get it. Can you repeat
magnetic.
it again? What? Can you
I'll
repeat it
let
again?
you know.
I
That
didn't
is
get
there
it.
in your book. Open your book. That is there in
It's
your
there
book.
in the book.
220, page number 226. That blue box.
Oh yeah. Two places of the magnetic needle becomes vertical and called magnetic poles.
Then plotting of magnetic field, you know that?
Yes, so that's the doubt
Yes,
I
sir.
have, sir. That's
That's
the
very
doubt I have.
easy.
No,
What
sir, for
doubt you have, Kenny?
non-uniform it's easy, sir. For uniform alone, can you explain, sir?
See, this is uniform, equal and equispaced. This is equispaced. This should be equispaced, and the magnitude should be equal.
Sir,
This is
but that
uniform.
I can find this, sir, because none of the magnets show like uniform, right? So everything connects to the north.
Exactly. You cannot find it naturally. We can produce it. Naturally, you
Oh.
cannot find it. We can produce it.
Yes, sir.
Sankalp, we define neutral point. What is neutral point?
Why is my leg keep changing, sir?
There's
don't know.
something called disable auto switch. Just click it.
Oh,
Who can define the neutral point?
sir. No, today morning only I learned. Neutral point is 0. I know that. Neutral point is 0. I know that.
Because it's
Sarun,
just neutral.
what's the definition of neutral point? I asked you all to revise this chapter,
So
everyone.
maybe it's the point where all the magnetic fields are equal.
No. Kongwei?
Sir, I don't remember. I didn't
It
study
is the
magnetic
point.
Magnitude on opposite.
It is the yeah. You are going partially correct. It is the point where Earth's magnetic field balances the
Earth,
magnetic field of the local magnet present there. Okay. Check your book. Check your book.
Okay, sir.
See the correct definition. The exact
If
definition.
a magnet is placed in a horizontal plane with its north pole facing towards the
So if written neutral points are the points at which two magnetic fields are equal in magnitude but opposite in direction. It's not written
Exactly.
Earth, but
Where? Which page?
229. Blue box of box.
9.
29.
Yeah.
Nitish, define
Pujada.
electromagnet.
The electromagnet is a temporary magnet that is powered by electric currents.
No, that is not a perfect definition. Anybody else?
So electromagnet is a temporary strong magnet made from a piece of soft iron, and it is activate
I was.
by the flow of electric current in a coil wounded around it.
You have to write it perfectly now. Electromagnet is a temporary magnet. 1 point made up of soft iron. Second point, it is wounded. Okay.
It is.
I
It is
said it, sir.
wounded. Yeah, you said it, but actually you were just saying it alternatively. You should be in a flow. Okay, current flows in the coil which is wounded around it, and it is an artificial magnet. 3-4 points you have to write. Okay, you open that. You open that exercise. First exercise. Okay, first exercise. It is a
Then A.
naturally occurring magnet. That stone rock is called. What is the name of that particular rock?
Lodestone.
Lodestone. Okay, they were natural magnets. Now open that exercise and go through each and every question and check whether you can answer that or not. Is there anything that you have doubt of?
Yes, sir.
Answers are there. No numericals are there. You just see that whether you are able to answer that particular thing or not.
Yes, sir.
Open your exercise,
So
everybody.
the entire exercise. The entire exercise.
First exercise.
Sir, which
Yes,
way,
sir.
sir? Which one? The magnetism, sir?
10A,
Sir, there is no
10A.
numerical, sir.
Yeah,
No,
10A,
like the
10A
entire
exercise, sir.
Oh my God. Wow, so it's so big, sir.
go randomly, go one by one, and check whether just check that you know this or not.
Wait, I already finished. I already
And
finished all
before
of
the
it.
exam, revise all the questions of the exercise.
Yes, sir.
Sir, this question, the new. So I don't understand this question alone, sir.
Which one?
So the second one C, B, second one C, neutral points of a bar magnet kept with
Hey,
its
how
north
do you
pole
go
pointed
there
towards
so quick?
geographically. I did this
Which one?
today
We
morning.
already finished it.
Yeah.
I'm thinking which question are you talking about?
So I'll ask. Can I ask the question?
Which one? Which one?
Sir, the neutral points of a bar magnet kept with its north pole pointing towards the geographical north are located dash dash.
Which question number? Just let me know.
B, second one, C.
B, second one. See, I'm not understanding.
I think it's different for maybe.
Yeah, in my book, I think it's different. Read the question again. Already. Read the question again. Read the question again.
Of a bar magnet.
So what's your
Wait,
okay, continue, continue.
wait. The neutral point of a bar magnet kept with its north pole pointing towards geographical north are located dash.
North pole pointing towards geographical north. Okay.
Is located are located there.
So that means geographical north, the magnetic field is going like this.
Yes, sir.
And just above it for this particular magnet. So from here, the magnetic field is coming out from here and going in the backward direction and then joining it here. Agree?
Yes, sir.
The magnetic field due to bar magnet will be opposite this side, and due to the earth, it will be this side above it.
Sir.
I think the answer will be above it. Check it.
Sir, the answer is on either side of magnet in east and west direction, sir.
Even that can be. Even that can be. See, I'll tell you.
So I don't
If you are
understand the answer there.
see. If this is the magnet, let us say this is the north side of the magnet, this is the south side. We are watching the magnet from the top, and this is the geographical north, this is the geographical south. So what happens? The Earth's magnetism comes out from the geographical south and goes towards the geographical north,
Sir.
right? Like this. From above
Yes,
it
sir.
and from below it also, isn't it?
Yes, sir.
But magnetic field due to this particular magnet goes like this. On the left hand side, it will be like this. On the right hand side, it will be like this. On the top also, this will be like this. And on the bottom also, it will be like this. Agree?
Yes, sir.
If this is the geographical now, this is the geographical south, this will be geographical east, and this will be the west.
Yes, sir.
So you can see that on the east side, it is this way. On the west side, it is this way. and the Earth's magnetism in both the cases is opposite. So on the east side also and on the west side also it can be 0, isn't it?
Oh, yes, okay. I don't.
What do you
Million IQ.
That is
Sir, so what is the answer?
either face of the east or west?
So when will they send this
Sir,
video?
I have a doubt.
Tarun, you go first.
Okay.
I just asked when will they send this video on the app?
I don't know.
It'll come by tomorrow. It'll come by tomorrow or day after tomorrow. Sir, I have a doubt. What is non-uniform magnetic field lines, sir?
Where the magnetic field is, the magnitude of the magnetic field or the direction is not constant.
Like,
Either its direction is changing or its magnetic field is changing. Value is changing. See here. This is the uniform magnetic field. Non-uniform magnetic field may be like this. Maybe
Yes,
like
sir.
this.
how can it be like that, sir? Oh, wait, when two magnets
Like
are next
is
to each other, north
converging.
and south.
Yeah. Understood?
Yes, sir.
See all the questions.
Sir, did you teach the angle between the magnetic axis of the Earth and the axis of rotation of the Earth?
That's rho.
Oh,
No, that was magnetic declination now.
sir,
Yes,
the
it was
textbook is
something like
given 70
alpha
degrees.
symbol.
Magnetic axis and the Earth's axis.
Yeah.
Okay. So that is angle of declination. And what angle you're talking about is different.
It's not rho, right?
You ask the question again.
So, the angle between the magnetic axis of the Earth and the axis of rotation of the Earth.
That is
Wrong,
angle of
wrong.
declination.
It is a question, Ra.
Oh, yeah.
Nothing. Well, yes, sir.
What question is it? What question is it?
A B third.
It's not a question. Oh, it's a question. Also.
I mean, like number.
Yeah, B fifth one. Sir, can you hear me, sir?
Yeah.
Sir, can you hear me, sir?
Yeah. I mean, you're audible.
Sir, can I tell my question now?
Hmm.
Is
The
it
angle
45 degrees?
between the shut up. Angle between the magnetic axis of the Earth and the axis of rotation of the Earth. Also in the textbook, it's given 70 degrees Celsius. I mean 70 degrees. Sankalp.
What is it given?
17 degrees, sir. It's written the magnetic axis.
That is constant. 70 degree around it is.
Given the magnetic axis of the Earth makes an angle of 17 degrees with the axis of rotation of the Earth. In the textbook, it's given like that.
Yeah. Hmm.
So if they ask you this, can I just put 70 degrees Celsius and then if it's a one word answer or one
It's not degree
Celsius,
Celsius.
sir.
It's not degree Celsius. It's not a
one
temperature.
70 degrees, 13 degrees angle.
Not
I keep
Celsius.
saying
It's 17 degrees. That is the angle between magnetic axis and the axis of the Earth.
oh, okay, so the magnetic axis is straight, right, sir, unlike the axis of the Earth. So
Magnetic axis.
So the magnetic axis is straight, right? So instead of like the axis of the Earth, which is slanted.
No, that is also inclined, and that's why it is 17 degrees with the axis of the Earth, because axis of the Earth is already inclined.
Yes, sir. Lodestone, it is a natural magnet.
Sir, I have a doubt from second chapter, motion in one dimension.
Okay, let's move to that. I hope
Okay,
I
sir.
wanted you to solve all these questions at home only, and then come here. But you have
Yes,
solved
sir.
that.
One, sir.
It's a
I didn't
numerical
know.
doubt only.
Let us move on to the second chapter. Any doubt? Go on with your doubts.
Yes, sir. I'll tell it 1 second. The question is, a spacecraft flying in a straight course with a velocity of 75 km per second fires its rocket motors for 6 seconds. At the end of this time, its speed is 120 km per second. in the same direction. Find the spacecraft's average acceleration while the motors are firing, the distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started. So this is question number 14 in
Yeah,
exercise 2C.
We did this question in class also, da.
See
Yeah,
here,
I
see here,
know.
see here,
Just
see
forgot.
here, see here, see here. So initially the velocity of the spacecraft was 75 kilometer per second. Finally,
Yes,
it
sir.
reached to 120 kilometer per second, and the motors were spotted for 6 seconds, right? Or 10 seconds.
Yes, sir.
6 or 10?
6, sir. 6, sir.
6, sir. 6.
6 seconds. So
6.3.
first of all,
So
acceleration. What was the acceleration?
I
Acceleration is
found
v minus v upon
7.5, sir.
20 by
I found
75.
acceleration.
Hello, am
I just couldn't
I
find the next
audible?
one.
So 120 minus 75 by
Hello, am
6.
I audible?
Yeah, audible, audible. So how much that is? That is 25
minus 75, which is
45.6. 7.5 meters
7.5.
per
7.5
kilometer
kilometers.
per
Yes, that
second
one I
square.
got. Next one, sir.
Then
The distance traveled by the
Wait,
10
spacecraft.
seconds.
Didn't
So
you
what
do
you
this
have to
in
do,
maths?
you have to use this formula. S is equals to ut plus half at square. Okay, and here you have to put t is equals to 6, u is equals to 75, and a is equals to the 7.5. Because for the first 6 seconds,
Sir,
it is moving with acceleration. First, let me
Which
complete.
this is the displacement for only the first 6 seconds, right?
Wait a minute. So this displacement you'll get for 6 seconds. Then for the rest 4 seconds, no acceleration is there. So there you can use the formula. There you can use S is equals to v into t. Directly you can use this. Because there's a constant
There's a
velocity that
formula
is
like
120 kilometer per second,
Yeah,
and time is 4 seconds. Understood? Try
Yes,
to solve
sir.
this.
That's
Get
what
the
I
answer.
know. I know the second part.
Try to solve with this and get
Okay,
the
sir.
answer.
why is
Try to solve with this and get the answer. Is your answer matching? Check it out fast.
what question number is it?
How are you gonna give some problems from the second chapter?
Yeah, we did like thousands, da. Okay, not literally, but we actually did like 20.
Pardon, Tarun? Any doubt?
Now, are you gonna give questions from the second chapter from the book?
No, I'm not giving questions. I'm just taking the doubts. We have done the questions in the previous class only. We did.
Oh, from
I
second chapter.
can't see a PowerPoint, sir.
Yeah, because sir is not showing it.
We have to do it on our own, da.
Excuse
So,
Okay.
me,
I
sir.
did.
Sir,
I
can't
wrote
see.
it there. I'm sorry. I wrote it there.
Which question?
Now is
What
it,
question?
is
we
it
have to do
visible?
it on our own.
Now is it visible?
Yes, sir.
Mhm. For the
Yes,
first
sir.
6 seconds, you have to apply s is equals to ut plus half at square. For the next 4 seconds, you have to apply s is equals to vt. Do that.
U is 25, T is
Yes,
6
sir.
plus half, A is 7.5, T is 6 square. I did cat
Uncle, what question number was this?
14th one, ra, at page number 60. Page number 60.
I'm getting 595 kilometers for the first 6 seconds, sir.
Okay, that's wrong because in the textbook they give 1065.
What?
Calculate all.
In the textbook they give 1065.
You will get
That,
that answer.
Hey, I said
Calculate
first one. I said first 6 seconds.
oh,
Calculate at the end first, you get the answer. Try to solve everything.
The first 6 seconds, which velocity should I use? The initial or the
Oh, okay, sir. I got it correct.
I wrote it there. It was like initially you have to take the initial velocity.
Oh,
Trying
sir, initial
every
is not
formula.
what
I didn't know it is. I got it
I have
correct,
written
sir.
75. See here.
1065 kilometers.
no, sir, not that, sir. S is equal to V.
For the second one,
V
here you have
into
to take 120. Here you have to take 120.
Oh, yes, sir.
I got it correct, sir.
0, 3,
Good. Let everybody.
I'll just
Is
drink water.
Cocktail is 7 point. Okay, nothing. I forgot the point.
Yes. Still, I'm here.
Still nothing.
Okay.
5, 0, 3, 35. No, 45. 0, 535. I'm ready for the exam, sir. I'm pumped up.
Solve. That's good.
Sir, I 4
Yeah.
sentences this term. Physics, math, biology, chemistry. I don't know about other subjects.
Hi guys, I'm back.
2, 1.
Sankalp, where are you? Sankalp went away. Caught in 4K.
135 into 2.
Sankalp is not here.
135 into 2 is 30, right?
Any more doubts here in this chapter? Any doubts? Any doubts?
No, sir.
No
doubts,
doubts. I
any
want to
chapter?
test myself. Sir, but it'll be so good if I can, if the exam like right now. So I have everything stored in my mind and then I can write it.
I didn't
Good.
study
What?
magnetism yet.
If you get full marks, who'll get full marks? You'll get a subscription for Champions Batch for the month.
Yes, sir. I'm very. Whoever gets sent them
Bro,
champion
sir.
virtual one.
We'll get YouTube Premium.
I don't know why, but I'm still scared, sir.
No,
No,
I'm
no.
pumped
Pretty
up.
confident.
Be confident. Be confident. Study more.
When you have a tournament of some sort, you all pumped up to beat the other guy up
Yeah.
like that.
You want one more
I'm pretty
question?
confident.
Sir, I'm
Yes,
scared
sir.
of these, sir. Because if I get
Why
marked
da?
one mark below him also, you start like, hey, you suck, you loser, you do, you lost, you cheated,
No,
everything.
that means you
Can't believe this case.
cheated, right? You have to prove that you did not cheat.
If you get below 70, you scammed.
You have to beat up our mouths with your marks, your
Hmm.
results.
Yeah,
Look at the motivational
it
speech,
should
bro.
fix our mouths with tape.
See here. See here.
Yes,
If
sir.
if a body.
Did you also get 585 kilometers for the first one? Kongwell.
Yes.
If a
29
body
Oh,
is
yes. Yeah, that's what I also got. Yes, so
85 kilometer for the first one, and second one it's
I didn't
480 kilometer.
to a planet
Uh,
having
So I'm happy that they won't ask gravitational constant
Fine.
questions. So. But they will ask
Who
them that
said?
are correct.
No, I asked physics ma'am today. Ma'am
and
said
that
you
of
make it.
see body is taken to a planet having radius 4 times that of Earth and mass half that of Earth.
I know that.
I know this, sir.
We did this in the
Easy.
Find the ratio of
ratio.
acceleration due to gravity at Earth and that planet.
Wait, the voice broke.
Done, sir.
That's soon.
That's good.
It's like mind calculation.
I thought you were gonna say Minecraft.
I asked Ramya ma'am if like those questions of finding the gravity will come. She said that it may come, and if at all it comes, they'll give the values.
So work with the numericals at one place and the 10 to the bars at other place. Then you'll be getting it easy. Okay.
Yes, sir.
No, what? I didn't hear you. What did you say, sir? I didn't hear you.
I said that you have to, for large calculations, if 10 to the power something is there, arrange that at one place and the numericals arrange that at the other place and solve them separately. You'll get it easier.
Yes, rough column.
Yeah.
Nitish, after physics exam, we'll have a meeting to discuss answer because the next day it's language paper.
Sir, have you written
I
4
can't
times
even
or
hear
sir?
you. I can't hear you. I
Four
can't hear
times,
you.
4 times. Radius 4 times, mass half. Radius 4 times.
We can't
Everyone
hear you,
done?
Nitish.
You're not
We
audible.
still can't hear you. Ha, you're muted. You're now unmuted. We can't hear you.
You better remove that device.
Throw it away. Where did Sankalp go?
No,
Oh my
not
god,
audible.
Nitish, we still can't hear you. And you, no, you're not audible. Change your input device, audio input device. Change. Audio, video settings, device, go, change. Nope, we can't hear you. Does your headset have charge?
Can you hear me now?
But yeah, now it's fine.
Yeah.
Hey, it's a wired headphones now. What do you mean?
Okay, tell me the answers. Tell me the answers.
I didn't get it.
Conway?
One is
Conway?
to 8, sir. 1 is to 8.
Nitish?
Nitish didn't get it.
Didn't get it,
Tarun?
sir.
Sir?
He
Okay,
didn't
see
get
here.
it.
See here. Force of attraction between a body. Let us say that is the planet. Having capital mass m, and between a small body that is having small mass m. So and the radius is r. So what is the force? G m upon r square. And with this
Yes,
force,
sir.
any planet attracts any body towards it. That is m times g. So mm cancel. What is the acceleration due to gravity? That is g m upon r
That's V
square, right?
M upon R square. Yes, sir.
So acceleration due to gravity
Sorry,
is
sorry.
directly
8
mass.
is to 1. Sorry,
Okay.
8 is to
So
1.
this is, let us say this is at Earth, and at that particular planet. Okay. For Earth it is more now. See,
It's
that
8
is
is
also
to 1,
kind of
my bad.
mistake there. Okay.
Yes,
Now
6.67.
8 is to 1.
that planet. So that planet is half of that of Earth. Mass is m by 2. Okay. And
Right, sir,
then
you can put
your
in R
radius
square,
is
sir.
r by 4. So that is to be squared.
That means the
Okay.
4 will come upright, sir. Because
Yeah.
that's
So
how
that
maths
4
works.
square will come up and this 2 will go down. So it will be 4 square goes up, Jim, and 2 will go down. Isn't it?
Common reaction force.
It's 32 by is
Gm
to
upon
1.
r square.
Oh, wait.
GM,
Never mind.
yes,
8
sir.
is to 1 is correct.
Now G
Sir,
at E.
how was it? Sir, where did the 2 go, sir?
So this 2
Shouldn't it
goes down
be
now.
It got
Oh, yeah,
cancelled,
16. Okay, 4 square is 16. Sorry. Okay, I thought 4 square is 8.
and it
Sorry.
got cancelled.
G at E by G at
Cancelled.
E will be, it will be Gm upon r square divided by 8 Gm upon r square. See, you have to write it in order. If they have asked first Earth and then planets, you have to write it in that way only. First
Yes,
Earth and then
I
planet.
got
Otherwise,
confused.
you'll get the reverse order.
What is the 8th
So it will be
answer?
r square into r square upon 8 Gm. So you will get G at E upon G at P as 1:8. Got it?
So Congo is right at the start and wrong at the end.
Understood everyone or not?
No.
So is it 8
It's
to 1
8
or
to
1
1
to
only.
1?
See, it depends on the. I'm writing. I'm writing. Is there a problem?
So I think if you're writing something, I can't see
Okay,
it. Sir.
okay. See. The mistake that I have done is that I have taken r by 4. It should be 4 times r, na? 4 r whole
It's
square.
32, right? 32 is to 1, right?
It's 4 r whole square. So 2 goes down and 4 is also downwards into 4 square. So it is not 8. It is 32. You made a mistake there, Sankalp.
Yeah,
Sorry,
let's
Pangu.
go. I know. I just said
Let's go,
32, sir.
sir. He only said 32, sir. He
I
didn't
just
make a
said
mistake.
32.
Yeah, sir. Congo didn't make a mistake, sir. I think.
Yes. So it is 32 here. So this 32 goes up. So it will be 32 is to 1. That is your answer. G at E by G at that planet will be 32 is to 1. That means
Then
Earth's
why would
gravity
Congo
will be
say
32
8
times
is to
more
1,
than that
sir?
of the planet.
I just
Okay, understood everyone?
corrected my statement. Yeah. Yes,
All
sir.
the best
Yes,
for
sir.
your exam. We have done the practice. We have done the revisions. I hope you'll do better. Best. Okay.
Yes,
5,
sir.
4
Thank you,
sentences.
sir.
Yes. Thank
All
you,
the
sir. Bye,
best.
sir. Thank you,
Yes,
sir.
sir. Thank you,
Sir,
sir.